In this problem, we have a block with mass 800 grams. It's at rest right here, near the edge of a frictionless table. A second block of mass 600 grams is sliding towards it at a speed of 4 meters per second. If the table is 1 meter above the floor, and the block sticks together after the collision, as you can see here, how far from the end of the table will they strike the floor? So what we're trying to find is how far from the end of the table will they strike the floor? Meaning, we want to know what this distance is. Now you might notice that's in the x direction, so we'll call that the displacement in the x direction. So looking at this, it looks to be somewhat of a projectile motion question. As soon as these blocks leave the table, the only force acting on them is the force of gravity. So that means you're going to have constant acceleration. If there's constant acceleration, this means we can use our kinematic equations. So we want to use the kinematic equations to find our delta x. But in order to know our kinematic equations, we need to know some information. We know this distance. So if you notice this is in the y direction. So we know that information. And we also know the acceleration in the x and y directions. So let's look at a table and see if we have enough information to solve this so far. In our x and y directions, our delta x, well, that's what we're trying to find. Our delta y, it starts here and it goes down 1 meter, so I'm going to say it's -1 meter. What else do I have? Well, if it leaves the table going horizontally, the initial velocity in the y direction is 0. Its only velocity is just in the x direction initially. We don't know what that is right now. We're not sure. What other information do we have? We have the acceleration in the x direction. As soon as it leaves the table, its acceleration is 0, assuming there's no air resistance. And in the y direction, gravity accelerates this object down. Let's see what we can find using this. Now, it looks like we have 3 things in the y direction, 3 variables in the y direction. So we might be able to find time. A fourth. 1, 2, 3, we can find time. Once we have time, then we have 1, 2 pieces of information. Well, we're going to need a third piece of information to find what delta x is. And that third piece of information, so we have 1, 2, that third piece of information, well, let's try to find the initial velocity in the x direction. Once we have all 3 of these, then we can solve for our delta x. So the first key is we got to figure out what is this initial velocity in the x direction. That initial velocity is whatever initial velocity in the x direction it leaves the table at. So how are we going to find out what that is? Well, maybe the collision can help us determine what that initial velocity in the x direction is. So I'm seeing over here a collision, so I want to use momentum. Conservation to find what that speed is. And then after that, we've got this problem where I use the kinematic equations. So our next step is find the speed of these 2 blocks after the collision. Collision, you use momentum. So our momentum is telling us this. M1, V1, M2, V2, This is our momentum conservation equation. This is before the collision, and then this is after the collision. So before the collision, notice this 800-gram block is at rest. It's not moving. It's got a speed of 0. Our 600-gram block is moving at 4 meters per second. And in between those two, I should have a plus sign. After the collision, well, our 600-gram block is going to be moving with some final speed. And our 800-gram block, because they stick together, two blocks stick together, they both have the same final speed. So it looks like, well, this is going to be 0. Looks like I can factor a v final and solve for this v final. We got to get that v final all by itself. So to get rid of this part, we've got to divide both sides by it. We put that in our calculators. Put this in our calculators, we find 1.7 meters per second. Now, if you noticed about the units, I'd have grams on the top times meters per second and grams on the bottom. So our grams cancel out. So in this case, it doesn't matter if we convert to kilograms or keep it in grams. If you ever don't know what to do, always keep it in kilograms. So that's our standard unit. Okay, so we just found 1.7 meters per second. Now we said that's our final velocity. Our final velocity. Well, that's the final velocity after the collision. Meaning, before the collision, this block was at rest, this was moving 4 meters per second. After the collision, they're moving 1.7 meters per second. So if we break our problem, our large problem up into two problems, one of the collision and one of the projectile motion, or the kinematic equations, you'll see that that final velocity is actually our initial velocity in the x direction. Meaning this value right here, 1.7 meters per second. So, in this problem we have now 1.7 meters per second is its initial velocity in the x direction. We're going to try, first look in the y direction. We've got 3 variables, so we can find what the time is, and then we're going to use our answer from the last part to find what delta x is. So let's try to see what's happening over here in a different table. Okay, so I've rewritten the table here, and if we look, we're trying to find the time. We're going to use the y direction because I have 3 variables. So our kinematic equation that includes all 4 of these variables is this one. We can sub in our values. We're going to try to solve for t. So if you notice, 0 times t is just 0, so we can cancel out that part of the equation. And to get rid of this value, divide by So now I'm left with -1 To get time all by itself, I want to take the square root of both sides. We plug it in our calculator and we find 0.45 seconds. Okay, so now I know my time, I know my acceleration in the x direction, I found my initial velocity in the x direction using momentum conservation. So I can find what my change in x is. Use the exact same equation, but instead of x, I'm going to use, or instead of y, I'm going to use x. Ax is going to be 0, so this whole term is going to just be 0. 0 times any number is 0. What I'm left with is delta x is 1.7. And this was the time that I just found. That gives me 0.765 meters. So great. Let's just review what we did. We knew the initial speed of this first block. The second block was at rest. So we could use the momentum conservation to figure out what speed both of those blocks are moving as it leaves the table. Then once I have the speed of the two blocks after the collision, at this point I can use the kinematic equations because the only force acting on these objects is the force of gravity. We have no other forces. If there's only one force, that means it's a constant acceleration. And again, we can use the kinematic equations. So then it turns into a projectile motion problem. Look in the x direction, look in the y direction. What we had to do, because we had 3 variables in the y direction, was we found time. And then once we had time, we had 1, 2, 3 variables in the x direction, so we can find what our displacement in the x direction was, or how far from the end of the table will the two blocks strike the floor.